Okay, in this question, we're looking at calorimetry essentially. What is the equilibrium temperature when substances at different temperatures are combined? And so we have like a coffee cup calorimeter here. We're putting something into water and there's a temperature change. Now, the goal here is to find that final temperature, which is the trickiest version of these, right? Remember, we have Q equals negative Q, basically. So we could say that the Q of the glass equals the negative Q of the water. Or we could say the Q of the water equals the negative Q of the glass. We just have to have a negative on there because one of them will lose temperature and one will gain temperature. So you're gonna have a negative temperature at some point and a positive, but they have to be equal. Here, we're gonna lay them all out and try to find that T final of each. Remember, first of all, we have Q equals mass times specific heat times change in temperature. Now, change in temperature is equal to T final minus T initial. So we're trying to find that T initial. So I'm gonna write them all out here. So mass times specific heat times temperature. I'm gonna put glass equals the negative mass of water So let's put it out. So we got 30.0 grams times 0.670 joules per gram degree C times T final minus 4.8 degrees. Now that equals negative 300 grams times 4.18 joules per gram degree C for water times T final minus 80 degrees C. Now, we have a little bit of a gut check here. The glass was at 4.8 degrees. The water was at 80. The final temperature should end up somewhere between those. It should not be negative. It shouldn't be 85 degrees or 100 degrees. It should be between 4.8 and 80. Now the mass of the water is much higher, so I would guess that it's going to be closer to the 80 than the 4.8, probably 70 something, 76 or something like that would be my guess. Now I need to solve and figure out if that's what I get. So I'm going to actually multiply through here. So I'm going to do 30 times 0.670, basically look at it as an algebra type problem. And I get 20.1 times T final minus 4.8 equals, we'll go 300 times 4.18. We get negative, don't forget those negatives, keep track of those, times T final minus 80 degrees C. Then I'm going to multiply that through. So 20.1 T final minus 96.48 equals negative 1254 T final minus 100,320. Big number. So now I'm going to get the two T finals on the same side. So I'm going to add the T final. So I'm going to 1254 to both sides. And I get 1274.1 T final equals, and then I'm going to add the 96 to both sides. And actually, this is a plus here because I did negative 1254 times a negative 80. Almost missed that there. So I get 104.16.5, we'll call it. Now I divide both sides by 1274.1. Keeping extra digits, and I get T final equals 78.81 degrees C, which is right around where I guessed. Right, I said about 76. So I'm going to go with 3. And when we're adding or subtracting, we're doing 1 in the, we're going by decimal places. So we have a decimal place here. So I'm going to go with 1 decimal place. So I'm going to say 78.8. There we go. Okay, a lot to it. Keeping track of a lot of things. The negative sign is the biggest thing to keep track of. And again, it could have been on either side. Eventually it's going to cancel itself out. And then I almost missed this right here, where the negative times the negative is a positive. But so keep track of that negative sign. A big algebra problem here.